Number 2, state whether the pressure of a fixed mass of gas, right, so the amount of gas isn't changing, we're not putting any in, we're not taking any out, if it will increase, decrease, or stay the same in the following circumstances. Okay, so we have 4 different sets of circumstances, and you notice that they only deal with temperature and volume. So what we're really doing here is we're taking the 3 quantities that we've been studying in this chapter so far, that is pressure, volume, and temperature, and we're seeing how they affect one another. Going back to this question, state whether the pressure, right? And so all of our answers down here are from the perspective of pressure. Is the pressure going up? Is the pressure going down? Or is it staying the same? Depending on whether the temperature is increasing or decreasing or staying the same, or volume is increasing, decreasing, or staying the same. Now, as we think about A through D here, I really urge you, I beg you even, to imagine individual gas particles as they fly around. Okay? Picture this happening in your mind. This is the sort of particulate understanding that I want you to have for the gases. So A, if temperature increases but volume stays the same, what are we knowing here? Okay, so the distance between the container walls isn't changing, but the average speed of the individual gas particles is increasing. So the distance they have to travel is staying the same. The speed at which they are traveling is increasing. That means they are going to hit the wall more often. There will be more collisions with container walls. And since we know that collisions are what result in pressure, right? If we have more collisions, we have more pressure, so the pressure increases. B, volume increases, but temperature stays the same. So the speed with which the gas particles move is staying the same, but the volume is increasing, right? And so the distance between wall to wall, the wall-to-wall distance is increasing. So they're going the same speed, but they have to travel longer distances. What's happening to the pressure? Well, the pressure is going to decrease. Why? If we remember that pressure is a result of collisions, but each of those particles takes longer in between collisions, there are going to be fewer collisions per unit time. Fewer collisions, less pressure. C, if the temperature decreases but the volume stays the same. So this is going to be the opposite of A. Right? The volume is staying the same, so that means the distance that these gas particles are having to travel is the same. That's not changing. Excuse me. But the speed with which they are covering that distance is decreasing. So it's going to take more time. And so you're going to have fewer collisions per unit time, therefore less pressure. D is the opposite of B. Temperature is staying the same, so the speed with which the particles are traveling is staying the same, but the volume is getting smaller, meaning the distance from wall to wall is a shorter distance. So going the same speed, but the gas particles have to travel a shorter distance, they're going to end up actually colliding with the container walls a lot more. And, like I'm wanting us to really understand, more collisions means more pressure.